Hey, what's up, y'all? Welcome back to Repetition and Animation Part 2. In this video, we're going to learn how to make this fun little animation that you see going on behind me here. We'll look at how to use a couple lerp functions, which are going to let us move these shapes around as well as color them with this gradient. And we'll also take a look at how to use keyboard input to kind of give us some control over our sketch. So, let's get started. This one's kind of a bigger project than the ones that we've undertaken before. So we're going to start by going and taking a look at sort of a list of all the things we need to do in order to accomplish this task. So first up, let's figure out just how to draw our shape. We're going to draw an oval using a p-shape variable just because we know there's going to be a lot on screen and we want to kind of save a little bit in performance, so we're going to use this p-shape instead of drawing the ellipse itself over and over and over. Next, we're going to figure out just how to animate it from the top left corner to the bottom right corner of our screen. Then we're going to draw a grid of ovals, and eventually we'll make that cover 4 times the size of our actual visible display window. We'll get to that in a little bit why. Then we're going to animate the grid, right? So we'll work on animating that grid. Then we're going to add our rotation in, and then finally we will add our color. So let's get back to processing here. Go ahead and make a new sketch. Do your regular old setup and draw. And let's start with making our size 640 by 480, and let's color the background white. Now we're going to use a p-shape, so let's go ahead and make a p-shape variable here. Let's call this one oval, and in setup I'd like to use create shape to make an ellipse, and we're going to draw this around the origin. And then let's just put in some dummy values here, 100 by 200. Let's go here. We're going to use translate. How about width divided by 2, height divided by 2. And then we'll need to actually draw our shape. Okay, so here we go. We've got an oval in the middle of the screen using a p-shape variable. Now, let's take a look at the method, or excuse me, the function that we're going to use to animate this shape across the screen. So processing has a couple of things that we're going to use to do that. The first is called a p-vector, right? And this is a data type that allows us to store like 3 different pieces of information in one variable, right? So we can store a vector in one variable. And so you would declare a p-vector type, you would give it a name, maybe something like PV or something more relevant to what you're doing. And then to initialize it, you can use this syntax, new p-vector. And at this point, you can give it, you know, an x, a y, and a z. It's also possible sometimes you don't need the z value, so you can just put an x and a y. And we're going to be operating here in 2D, so we won't need a z value for our p-vector. Now, this data type also has a function called lerp. So you can use the lerp function on a p-vector, right? And this lerp function takes a starting vector, an ending vector, and then it has a sort of a control here. You can think of it in like a percent. So what percent between the starting point, the ending point, do you want to, is it going to return? So if I've got a little screen here, and my first vector is over here, and my second one is over here, right? So somewhere along this line, there's a bunch of different vectors. There's a bunch of different points, x and y coordinates, right? So if I'm saying start and end, right, and my percent happens to be, this value goes between 0 and 1. If it happens to be, you know, 0.5, it's going to find the exact center point between these 2 points. If I make this number 1, it'll be at the end. If I make it 0, it'll be at the start. And so any number in between 0 and 1, so 0.25 is here, 0.75 is here, right? So this lerp function is going to return a vector in between these 2 points based on what you put in this control point. And so we can use that, right? So we can basically, like we were doing with the previous sketch, where we just kind of increment some counter or some value over time as the sketch runs, we can change this percent over time, and it will return a vector in between our start and end points, and then we can translate the shape to that vector. So let's take a look at how we can do that in our code. Let's go ahead and make 3 p vectors. We're going to have start, end, and the current position, right? And since we're going to draw it from the top left corner to the bottom right corner, I know that I want my starting point to be equal to a new p vector at 0, 0, and I know I want my ending point to be at a new p vector at width and height, and we're just going to initialize the current p vector to be at the starting one. Now, in draw, we need to come in here and say current equals p vector dot lerp, right? And we're going to go between the starting point, the ending point, and we need some kind of variable here. So let's make a float, and we'll call it t, right? Just thinking in terms of like time. And let's set t equal to 0 in the beginning. We'll put t here. And instead of translating to width and height, we're going to translate to the current x position and the current y position, right? So let's run our sketch and see what we get. There we go. We've got our ellipse up here in the top left corner of the screen. So if we want it to move along that line, then we're going to need to increment t, right? Maybe we can say t plus equals 0.01. And as t increases, you'll see the shape start to move from the top left to the bottom right. And of course, because I have not limited the amount that t gets incremented to, we leave the screen. So let's fix that. Let's say, how about t equals constrain t plus equals 0.1 between 0 and 1. And let's see what happens now. Okay, so that is looking pretty good. All right, now let's see about drawing this shape in a grid. So we're gonna actually not move it around for a second. And we're gonna think a little bit about how we can divide up our screen into rows and columns so that we can make a grid of shapes here. So I'm gonna say int rows and cols, right? Maybe I want, how many rows do I want? I think I want 6, and I think the number of columns that I want is like 20, right? And in order for my ovals to kind of not overlap with each other, I'm going to actually set the width and the height of them based on the number of rows and columns I have. So let's see, the width is going to be determined by the columns. So I can say width divided by columns. And then over here I can say height divided by rows. And that will make my ellipse the correct size. Because then I'm going to come down here and create a set of nested for loops, right? So I might say like for int I equals 0, I is less than rows, I plus plus, and then inside of here I'll say for int j equals 0, j is less than columns, j plus plus, and then I can come into here and move my code here. So now we need to actually use our counter variables here to calculate x and y offsets. so that we can add those offsets to the actual position that this sort of, first shape, where we're basing the position of all the other shapes off of, is moving. So let's make a couple more variables. How about x offset and y offset, right? Then we can come in here and we can say y offset equals map j, which we know goes between 0 and rows minus 1, between 0 and height. Oops, sorry, I. And then here we can say x offset equals, this one is j, so map j, which we know goes between 0 and columns minus 1, between 0 and width. Okay, and then we're going to add the x offset to our current x position that we're grabbing from that p vector, and we're going to add the y offset here. And let's see what we get. Okay, so here is our grid of ellipses, and you can see it's really important that we actually have sort of a symmetric edge of our grid here, because we want to make sure that when we loop our animation, it looks the same at the beginning of our loop as it does at the end, right? Okay, so now that we've got a grid, let's look at animating it, and that will reveal why we need to actually make this grid sort of 4 times as large as it is right now. So let's turn this back on. And you can see, since this is sort of the first shape that's getting drawn, and everything's getting drawn relative to this shape, as we move that shape across the screen, we lose the rest of the grid and you can't really see anything. This is just empty space, right? So what I did in order to kind of solve that issue was draw, so we were looking at, let me see if I can kind of draw something. So here is, the screen that we can see. And so if we just draw what's on the screen, when we move it this way, we lose all of, by the time our ellipses get over here, there's just nothing on the screen. But if we draw a grid of ellipses that is actually 4 times, right, the size, and I start my shape up here, it will fill this entire grid, right? So you'll see the ellipses down here, even though they're starting here, and I'll just translate, right? I'll just move this ellipse down this way, and I won't actually ever have any blank space, right? Because this will push this grid here, and then you have these 2 grids that are going to fill in any white space as this grid moves down. And then once it gets here, you can just reset it and loop it over and over to have that sort of continuous animation effect. Okay, so let's take a look at how we're going to do this in our sketch. So what we know is we actually don't want to start here at 0, 0. We want to start at negative width and negative height. So we want to be off the screen when we first start. And we don't want our ending point to be all the way over here. We want it to be the origin, 0, 0. And so if I don't change any of this code, and I just run the sketch as is, you can see that there will be a little 1 ellipse here. We can see just the sort of tail end of our grid, right? So now that grid is in that top left corner, thinking in terms of those 4 grids that we were just looking at on the paper, right? And then that's t equals 1, right? So this t was 0, t is equal to 1. So obviously we need to come in here and change the mapping and maybe the number of repetitions that we do, so that we can actually fill up the screen in both dimensions. So let's turn this off. And let's start by seeing if we can spread things out vertically. So we're going to double the number of rows, right? Because if we look at this again, right, you can see this would be the regular number of rows that we define. We actually need double that number. So we're going to go back into our code and say rows times 2. And we know this is rows times 2 minus 1. And we don't want it to go between 0 and height. We want it to go between 0 and 2 times the height, right? And we'll actually do the same for our columns. And we want this to go between that and 2 times width. Let's take a look and see what that does for us. Okay, it's looking okay, but it's not quite symmetric around the edges, which means it won't loop. So actually what we need to do is make sure that it draws one extra shape on the end, just since these ellipses are getting drawn from the center. So we can change this conditional here, change this conditional here, and now these will actually be equal to, so that'll run all the way through to that value. Okay, now you can see we're back to this grid that is fully symmetric all around the edges. And if I run the sketch again with t getting incremented, you can see that when t is equal to 0, it looks like this, and when t is equal to 1, it also looks exactly the same, which means we're going to get a nice smooth loop. Okay, so let's now see if we can loop this. So we'll say if t is greater than or equal to 1, right, we want to reset. We're going to say t equals 0. Let's see if that kind of... Okay, it looks like it's nice, smooth, seamless loop here. My computer's struggling a little bit because it's also capturing this video and running processing at the same time. But there's a couple other things we can do to help the performance of this. You know, we're drawing a bunch of different ovals, and a lot of them we're not seeing, right? So maybe we actually only want to draw an oval if it's being seen. So let's have another couple variables. Let's say float x and y, right? And what we're going to do is we're going to calculate, and we're going to check and see whether or not these values, right? So we'll say x equals this expression. Right? We can replace that here. And we'll say y equals this expression. And replace y here, right? And what we're going to do is we're going to say if our x value is on screen, so x would need to be greater than 0, right? So it needs to be greater than 0. If x is greater than 0 and x is less than width, right? So we want it to be still on the inside of the screen there. And y is greater than 0, and y is less than height, right? So if we're on the screen, then I want you to draw the shape. And let's see what that does for us. Okay. And as you can see, right, we're clipping in and out a few of these here. And that's because the ellipses are getting drawn from the center, right? So sometimes the ones that would be over here are not, the center of it is not quite at 0. So we actually, what we need to do is we need to take the width of our ellipse, or at least the cell, right, the division that we're thinking of, and say as long as it's greater than negative that. Okay, so that'll take care of the clipping here. I think I'm seeing a little bit of clipping on that side as well. So let's add another ellipse worth of width to that conditional there, and then we're clipping in and out on the top and the bottom as well. So we'll need to take the height of one of our ellipses and check for if we're in negative that height or positive, height plus one extra one. Okay, and so now you can see we are only drawing the ones that we need, and we're not losing any of them up or down. Okay, so this is looking pretty good. I think visually, I also, in the example code, gave these little dudes a little more breathing room. So I'm going to make this only 90%. The shape itself is only going to be 90% of that calculation. Okay, so now they have a little bit more breathing room. Cool, let's add the rotation in, right? So we need another variable, let's say float angle, and we'll set it equal to 0 to begin with, just to initialize at 0 here, and then let's calculate angle is going to get mapped, a mapped value of t, right? Because t is, goes from 0 to 1, and that controls the looping animation, and I want this rotation to line up with that loop. So I'm going to say map t, which goes between 0 and 1, and I want to map this, let's do a 180-degree rotation. We'll say 0 and pi. And then here in our code that's actually drawing the shape, we'll say rotate angle. And let's see what we get. Okay, this is looking a lot closer to what we had in the example code. Let's wait for one full revolution here to just make sure the loop looks pretty good. Yeah, okay, that looks nice. Excellent. So I think now all we need to do is color this in. So let's think about how this gradient is going to work. We're going to use another lerp function. This time we're going to lerp a color instead of lerping a vector. So processing also has color variables, and so you would just say color, you could call it C, right? And then you can make a color variable. We're going to use our RGB again, so then, well, if I want blue, I would say 00255, right? So now this color variable is storing this actual range set of color values, the 00 and 255. So lerp color acts very similar to this regular lerp function, right? Where you can say lerp color, and then you would have like C0, C1. So you have two colors. You would define two color variables, and you're going to go between those two colors, right? 0 and 1, by some percent, right? And again, this value goes between 0 and 1. And so if you think of, I think the colors that I used for the example was like blue and teal, right? So if I say C0 is blue and C1 is teal, then this lerp color will find the color in between them. So like half blue and half teal. If you add those colors together, that's what lerp color is going to give you when you put 0.5. This would be 1, this would be 0, right? So let's think about how we want this lerp color function to actually work in our sketch. I'm going to just flip the page here. So we can only see a little bit of the total picture that we are drawing, right? So this is what we can see, but this is what's actually being drawn. And we're only going to really change the color in the horizontal direction, right? So we're going to make the gradient be horizontal, and we don't really care about vertically what the gradient is going to be, because all the vertical colors are going to be the same. So we can just think about this lower half, right? And what we're going to do is we're going to take sort of a segment, right? We want like to split this in half, right? And when we're going to use I, again, to map the color, right? So we know I is going between 0 and columns times 2, right? So we know that I will be 0 at some point, it will at some point be equal to columns, and it will at some point be equal to columns times 2. So what we want to do is we want to map maybe C0 to C1 to C0, right? So we'll have this nice gradient color that's sort of wrapped around, right? And as t, so let's say this would be t equals 0, right? If this is how we're mapping the color out, when t is equal to 1, right? So here's our screen, right? And we've moved this grid over, right? So we took this and we shifted it this way, right? So now C0 is on the left side of our screen, C1 is on the right side of our screen, right? And C0 is here. So this is t equals 0, right? And then it's going to loop around, right? But if I don't change the color mapping when it loops back around, you can see there's going to be a little bit of a jump, right? Because this is t equals 1, right? Because when t equals 1, C0 is on the left side of the screen, but when t equals 0, C1 is on the left side of the screen. So I need to have another way. Let's say that, maybe this is all phase 1 of my color mapping, right? And phase 2, I know that I've reset the position of all my shapes, right? So they're back to like they were over here when t was equal to 0, just like before, right? Because we reset t back to 0. But instead of having C0 to C1 to C0, I need this picture here to look exactly the same, right? So I would have C0 to C1, and C1 would be over here on the part we can't see, right? And then as the animation runs, again, right, and it moves this way, and then this part of the screen is off, what we're going to end up with is C1 to C0 to C1, right? This is t equals 1. And this is sort of like phase 2 of our color mapping. Okay, so this will make a lot more sense, hopefully, once we put it into the code and you can kind of see what's happening. But this is how I'm thinking about my color mapping, and this is what we're going to implement. So you can pause this and take a look and kind of wrap your mind around that if you need to. Let's go back here and start by just creating some color variables. We're going to need color C0, C1, and maybe I just have something called C. That's what I'll actually use to set the color of my shapes. So for now, let's just work on the first phase, right? What we'll do is we will say we need to, we're mapping J rather, because we're gonna be spreading this color out horizontally. So what we will do is we're gonna say color C. We need to also at some point define our color variables. So let's say C0 equals color, I think I said blue, and C1 equals color, and this was going to be teal. Right, okay, so now we've initialized these two color variables. Now we can come in here and we can use that lerp color function. We can say C equals lerp color. So I want you to find the color in between my blue and my teal. And we are going to map J, right, which we know goes between 0 and, we're going to segment this, right? So we will say columns, right, for now. We want it to go between C0 all the way to C1. So we'll say C0, which is at 0, and C1, which is at 1, right? And I need an extra parentheses here to close that up. Okay, and actually what we're going to do is we're going to say if J is less than columns, then I want you to map it this way. And otherwise, if it's greater than columns, so we're in that columns to 2 columns range, I want you to map all the way from C1 to C0. And let's see, oh, well, of course, I also need to actually set that color. So then I would say oval dot set fill C. Oh, the mapping here is not correct. Okay, so columns, we're going between columns and columns times 2 here. That should solve that. Okay, now that I've defined the ranges correctly, should have this nice gradient. And you can see it wraps around. It's blue, dark blue, it goes to teal, and then the left side that we weren't previously seeing, but now we can see is blue, right? So there's that C0. Okay, and as you see, when it loops around, it jumps. So we need to implement that second phase. And also, I think I had turned off, I would say, oval dot set stroke false, because there was no stroke for that P shape there. Okay, and I need something to just keep track of the phase, so I'll say int phase equals 0, right? So if yada yada, if phase is equal to 0, then let's do our color like this. Otherwise, when phase is not equal to 0, let's do it differently. And so what we'll want to do is we will say every time we reset, if phase is equal to 0, then we're going to want to change the phase to 1. Otherwise, if phase is equal to 1, we want to set it back to 0, right? And so that will change this here for us, and now we can come in here and we can do the same thing, right? But instead of going from C0 to C1, we actually want to go from C1 to C0, right? And so this left part of the screen that we can't see, we want it to go from C1 to C0, and then the right part of the screen that we can see when t is equal to 0, we want it to do just the opposite. We want it to go from C0 to C1. And I think this should work. Let's take a look. Okay, sweet. So now we've got a working animation with the color gradient working as intended. All right, this is super great. Let's now take a look at the last thing we can do today. Let's take a look at putting some keyboard input here. Maybe I want to just like switch the direction. So we're going to use a function called keyPressed. And inside of keyPressed, we can add conditionals to check for which key was actually pressed. So we'll say if key is equal to, and this is a space, this is the space bar, there's nothing here, right? If I wanted to make it the A key or the 1 key or G or whatever, right? I would put that there. But for now, I'm going to use my space bar. So if key is equal to space, then do something here, right? And what I want to do, right, is actually change the direction, right? I want to change how am I going toward t equals 1 or toward t equals 0. So what I can do is I can say float speed, and we'll initialize it as 0.01, right? And then instead of this hard-coded value, I can say speed. And what I can do is in here, I can say, well, let's use a variable also to control, how about Boolean forward, right? So are they moving forward or backwards? And we'll set this equal to true for now, right? So basically, this is just going to move the shape across our line, but we do need something to control, and check, well, should we be looking for, what direction are we heading? Is t going to get greater than 0, or is it going to be going less than 0, right? So we'll say if we're moving forward, right, if that Boolean variable is true, and we are in fact going forward, then do all the same things we were doing before, right? However, if we're moving backwards, right, and speed is somehow negative, right, so we're going to also change, so we'll say if speed is greater than 0, right, so if it's a positive value, speed times -1, we want it to be, times equals -1, right? We want it to be a negative value, right? Otherwise, if it's a negative value, we want it to be a positive value. So we can again multiply it by -1 so that it will flip and go the other direction, right? So when I press this key, my space bar, it will change this. So it will now, instead of looking and seeing when t reaches 1, we'll say if t is less than or equal to 0, because now we're traveling backwards across this line and we're decrementing t, right? So if it is, then we will reset it back to 1. And I think that's all we need to do. I might need to flip these phases as well, but let's test it and see what's going on. So I can send it back the other way. Just by pressing the space bar. And let's let it loop a couple of times just to make sure the color gradients remain intact. Yeah, that seems to be working. And I'm going to hit the space bar again. And you can see I'm now... Oh, that's interesting. Okay. What did I do here? Oh, I see. This actually, okay, it's because it's always being set to false. So what I need to do is I need to actually say forward equals the opposite of whatever this was before, right? So this not operator just flips that Boolean. So forward is going to start out as true, and when I press the spacebar, it will become false, right? And that means when my speed, which is positive, is above 0, it will become -1. Right now we're in this state where forward is false, speed is a negative value. So when I press space again, forward will become true, it'll get flipped, and then because speed is a negative value, it'll get multiplied times -1, it'll become a positive value, right? Okay, so I think this should work now. Okay, so we're going forward, that's all good. Let's come back. Nice. We'll press the space bar again to send it this way. Okay, and now my sketch, right, now it's a playable visual, and I have this little space bar that I can make these dudes do their little dance. They can wiggle back and forth. So you can kind of see how you might sync this up to a piece of music, or make it like an interactive art piece that people can kind of play around with. Just one button. Just the space bar. Yeah, it's pretty fun. Cool. I think that's everything I wanted to cover in this video. So join me for the next one. See you next time.